The moon was supposed to be finished. Finished forming, finished changing, finished surprising us. For more than 50 years, we treated our nearest neighbor as something close to a solved problem. We had mapped its craters, collected its rocks, and walked across its surface. By the end of Apollo, the moon felt less like a frontier and more like a museum. Then Artemis II carried human beings behind the moon again. In April 2026, 4 astronauts traveled around the far side and saw its hidden landscape for themselves, returning human attention to a mystery that robotic missions had been building for decades. Because the moon did something no one fully understands. It became 2 different worlds. And if we cannot explain how that happened, we may have misunderstood far more than the moon itself. The original story seemed simple. Around 4.5 billion years ago, according to the leading models, a large body collided with the young Earth. Material released by that event eventually gathered together and formed the moon. One origin, one object, one broadly shared starting point. Yet, the moon did not evolve uniformly. The side facing Earth became flooded by enormous plains of ancient lava, creating the dark regions visible without a telescope. The far side tells a very different story. Volcanic flooding was far more limited there, leaving much more of the ancient highland crust exposed. The hidden hemisphere is brighter, more heavily cratered, and almost completely missing the vast, dark plains that define the familiar face of the moon. Imagine finding 2 halves of the same fossil and realizing that each had preserved a different history. That was the problem lunar scientists faced. When spacecraft finally mapped the hidden hemisphere in detail, the contrast was impossible to ignore. The near side is dominated by enormous volcanic plains. The far side is not. Instead, its surface is covered by ancient highlands and impact scars that have survived for billions of years. Part of the explanation may lie beneath them. On average, the far side crust is roughly 20 kilometers thicker than the crust facing Earth. That extra thickness may have acted like a barrier, making it far more difficult for magma to reach the surface. That could explain much of the missing lava. But it does not explain why the crust became so uneven in the first place. Both hemispheres began as parts of the same world. Somehow, they evolved along profoundly different paths. NASA lunar scientist Noah Petro has described them as telling 2 completely different stories about the moon's history. And the deeper researchers looked beneath that battered surface, the stranger the story became. Because hidden below the moon's largest impact basin was an enormous concentration of mass that no one expected to find. The first clue lies beneath the South Pole Aitken Basin. At roughly 2,500 kilometers across, it is the largest recognized impact basin on the moon and one of the largest known anywhere in the solar system. Laid across the United States, it would span roughly the distance from Los Angeles toward Chicago. The basin formed more than 4 billion years ago, although its precise age remains uncertain. Then researchers combined gravity measurements from NASA's Grail mission with topographic data from the Lunar Reconnaissance Orbiter. They found an enormous region of excess mass extending deep beneath part of the basin, heavy enough to produce a measurable distortion in the moon's gravitational field. One explanation is extraordinary. Part of the impactor's metallic core may still be embedded within the lunar mantle, but that is not the only possibility. Either way, the impact left behind more than a crater. It left a structure deep inside the moon that scientists are still trying to identify. Then came the granite. In 2023, researchers reported evidence of a granitic system roughly 50 kilometers wide beneath Compton Belkovich on the lunar far side. Granite is common on Earth, where water-rich magmas and plate tectonics help create enormous bodies of silica-rich rock. The Moon has neither of those Earth-like systems. Small amounts of lunar granite were already known, but a buried formation of this apparent scale was something else entirely. Then there are the swirls. Bright, twisting patterns stretch across parts of the lunar surface as though someone dragged a brush through wet paint. The Moon has no global magnetic field today, but some of its rocks preserve magnetism acquired early in its history. But the complete story remains unresolved. Each explanation answers one question and opens another. For approximately 40 minutes, Artemis II disappeared behind the Moon. The lunar body blocked Orion's radio link with mission control, and live telemetry could no longer reach Earth. Then Earth disappeared below the lunar horizon. When Orion emerged again, Earth rose above the Moon as a small blue crescent suspended in darkness. Artemis II was officially a systems test. Psychologically, it was also a rehearsal for going farther. The silence behind the Moon lasted less than an hour. The distance to Mars will reshape communication itself. The central questions remain. Why did volcanic activity become so concentrated on one hemisphere? How did such a large granitic system form under lunar conditions? And what exactly produced the enormous mass buried beneath South Pole Aitken? Sometimes the anomaly fades, sometimes our understanding changes around it. We still do not know which kind of moment this is. The Moon did not change after Artemis II. We did. Perhaps that is what exploration does best. It does not simply reveal unfamiliar worlds. Sometimes it forces us to look differently at the ones we believed we already knew. The universe does not always hide its deepest mysteries far away. Sometimes it leaves them hanging in the sky every night, waiting for us to look again.